Thank you. So this is also not just on the benchmarking, but also on your topic. I guess you asked for the model problem, and yeah, and the idea was first the motivation. So the idea was that we want to apply these ideas from your paper with this pathwise instability, and we searched for a model problem, and the idea was to go beyond multi-level Monte Carlo and use multi-index Monte Carlo. I think we talked it through and it doesn't seem to work, and I also ran numerical experiments, so I don't think this will work. But yeah, but just to motivate the model problem, advection diffusion reaction equation, so maybe nonlinear or linear, such as given above. And yeah, the idea was to apply these ideas from Rob's paper to stabilize it at least pathwise. And multi-index will most probably not work because the artificial diffusion and the H, they are coupled, and so this idea of multi-index is not applicable. And yeah, but besides that, we thought this problem is a great Troy problem for benchmarking, and that's why this is also appearing here in this benchmarking sheet here. I don't, Linus, do you know how to switch slides here? Oh, yeah, this is an sample, so I random Darcy flux. And yeah, 2 sample computations and also 1 unstable one. Yeah, sure. So again, this is the problem, and I took a random Darcy flux Q here and made some computations. I computed Q with a classic whatever elliptic problem and log normal fields, took this flux and plugged it in, and then yeah, 2 yeah, small problems such that it's still computable on my laptop in a few minutes or even less. So this is just randomly transported down here, and I think it was a minor diffusion. And then here another example where I place these random rocks and then again elliptic problem, and here I chose it such that the Piclet number is really large, and you can see it's getting unstable. So this is the problem we want to tackle. And so I also raised, I also thought like maybe this could be solved with the penalized DG. So the penalizing the diffusion part, and then maybe using this penalty parameter in some sense. Again, I don't think multi-index will be applicable, but at least yeah, increasing the penalty with the level. This should work, but it will be very expensive. So I guess Linus is not Linus. Linus is taking over with the benchmarks.
Yeah. So bit as a summary for what we currently have regarding the benchmarks. The idea is that first of all, we need something like reproducible models that are also portable, so that people don't really have to go through an installation effort or something. This is what we currently have through Umbridge. There's also a set of online documentation. I mean, I didn't show it during my talk very much, but I guess since we've got a couple of minutes left, maybe I'll just briefly show you. So basically, there's this nice logo that Anna Reinertz came up with, and we have so far 2 documented models. There are a couple of other ones work in progress. For example, there's this sort of cantilever type beam model that Matthew Parner wrote. We always have documentation like how to actually run the benchmark. There's some properties like what the input and output dimensions are, whether it supports gradients, and in this case, well, there's no additional configuration. Got some documentation describing what the PDE is that is being solved in that benchmark or in this reference model. And based on this model, which is now just mapping inputs to model outputs, we also have an inverse problem that Matt has come up with, where we essentially have the same thing. You can directly run this container. You've got the 3 input parameters being these 3 material properties for this beam. And the output is an evaluated log posterior as documented below. So in that spirit, we plan to continue adding more models. As Niklas already mentioned, the interesting thing is once you've got this Umbridge interface, you can easily wrap the whole thing up into a container and immediately reuse it as a benchmark. So the idea would be that we just try to wrap this model up. That could serve playing around with multi-index a bit if we come up with some ideas. And also the exact same work can then serve as sort of a standardized model that other people can use as well for their testing. Going forward, so adding more benchmarks is one thing. Of course, there are certain aspects that should be taken care of. So far, the benchmarks that we have are focused around inverse problems, but obviously you can also use the same models to define some interesting forward UQ problems. This is something we should definitely add. And the goal is that maybe within the next few weeks, we'll have a meeting with people who are actually interested in driving this forward. We'd settle on some benchmarks that would be interesting for the community and have this sort of a fixed benchmark suite that we can publish as sort of a whole. Yeah, and one idea that we had was that we could maybe couple this publication for these benchmarks directly with sort of a review regarding UQ methods. For example, in Mac, we have a lot of MCMC methods implemented, and we could just put them against each other in exactly identical problems, highlighting how they behave in certain situations. And I think the same could also be extended to other types of methods. Finally, there was a nice idea from Abdul, which was, I guess, lowering the bar for entry is one of the main goals here. So we currently have C++ and Python integrations, as well as one specifically for Mac. But also PyMC3 would probably be a very good idea to make sure that you have a very smooth integration, and whenever you have a PyMC3 code, you can directly access these benchmarks or any other rich models as well. I think that would also help in taking it forward. Right, so I think from our side, that was pretty much it. Hope it's enough considering that we are a group of 2 people. And
great.
Yeah, so yeah. Thank you.
Thanks.